Okay, in the previous lectures we have used simplex method to solve any type of linear programming problem. However, there is another method, allocation method, which is applied to a lot of very practical problems. Generally, this method is known as transportation problem, transportation model, or transportation problem. We describe the approach which is used or characterize this problem as deterministic approach. Transportation problem, one of the forms of deterministic method, because the decision making process in this field is based on certain information and data. That's why the decision concerns with the problem of transportation is taken under certainty. Certainty means the data and information are available and valid. So the objective of transportation problem as deterministic method is to transport products, goods from more than one center known as sources, origins, requirement centers, etc., capacity centers, to more than one places called destinations. Sinks, demand or requirement center, market centers, etc. And the cost of transportation from each of the origins or source to each of destination being different and known. So the matrix of the transportation problem consists of cells. These cells consists or contains these cells contain the cost of transportation 1 unit from I source to J destination, from the production center to the market center. So the cost of this transportation problem is linear, and the problem is to transport the goods from various origins to different destinations in such a manner that the cost of transportation is minimum. So the final objective of transportation problem is to take an optimal solution that minimizes cost. To take an optimal decision that minimizes cost. This is short acknowledgement introduction with the transportation problem. First is deterministic method. Its objective to minimize the transportation from various production centers to various market centers. The costs of transportation are linear, unknown, etc. Okay, again, to recap the definition and characteristics of transportation problem. Transportation problem is a special kind of linear programming having objective to minimize the cost of transportations of goods from M source to N destination. Let us break down this short definition. First, transportation problem is special form or kind of a linear programming problems. So transportation problem belongs to linear programming. 2. It is respectively deterministic method. Kind of linear programming, respectively it is deterministic method. Its objective is to minimize the cost of transportation of goods from M source to N destination. So it deals with identifying an optimal solution of transportation and allocation of resources to various destinations while keeping expenditure to a minimum. Expenditure of transportation to be kept at a minimum. Assumption. فرضيات مشكلة النقل. The supply level of each source and demand level of each destination are known. The cost of transportation of one unit of product from SJ to DJ is known. The total of supply equals to the total of demand. Otherwise, rearrange the matrix. Rearrange the matrix. These assumptions push us to disarticulate the matrix of transportation. The diagram of this matrix had column, so consists of columns and rows, cells. Okay, the upper row of the matrix represents the market centers or destination. The right side of the matrix represents the quantity of stocks or supply. The left side is options or source. Inside the matrix is cells. Each cell represents the intersection point between the row of demand, between the row of supply and column of demand. So cell is intersection point between supply and demand. Inside each row or cell there is stated cost, given cost. The cost of transportation 1 unit from source 1, for example, to D1, from source 1 to D2, from source 1 to D3, etc. Now, as we mentioned before, the main objective is to minimize the total cost of transportation. We have the optimal solution to take an optimal solution which lead to minimize the total cost of transportation. Generally speaking, these three assumptions are the main. Objectives, of course, is to minimize the total cost of transportation. Okay. Types of transportation problem. Now, I would like to re-announce the validity of using a transportation problem is restricted conditionally. The quantity of supply should equal the quantity of demand. We can apply transportation solution if the quantity of demand equal the quantity of supply. Otherwise, we need to rearrange the matrix in order to satisfy that condition. That's why we distinguish between two types of transportation problem: balanced transportation problem and unbalanced transportation problem. The transportation problem is said to be balanced when the quantity of supply and quantity of demand are equal. Then the problem is said to be a balanced problem. Unbalanced when supply and demand are not equal. So the satisfy of application, the solution is not satisfied. Then the problem is said to be an unbalanced problem. In this case, to avoid the status of unbalanced problem, we need to create or to add a dummy row or a dummy column. Based on the requirements to make it balanced problem with zero cost. With zero cost. So, there are various methods of transportation problem, but the main of them which meet the requirements of our discipline course are three: north west corner methods، طريقة الركن الشمالي الغربي، least cost methods، اسلوب اقل التكاليف، فوجل approximation methods، طريقة فوجل التغريبية أو أسلوب الجزاء penalty. Now these are known as the main methods of transportation problem: north west corner methods، طريقة الركن الشمالي الغربي، least cost method، طريقة أقل التكاليف، فوجل's approximation methods، فوجل عالم من العلماء بتاعنا في العمليات، فوجل's approximation، طريقة فوجل التغريبية. We have balanced problem and unbalanced problem and three methods of transportation problem. Three methods of transportation problem. Let's try to apply each of them practically using an examples. One look to the structure of transportation problem. The matrix below shows on the right side, the column on the right side of the table S1, S2 and S3, the quantity of supply. The first column on the left side consists of three sources: 1, 2, 3. The upper row is destinations, market center, say D1, D2, D3. The lower is the quantity of demand, D1, D2, D3. Okay. Now let's follow. The upper D1, D2, D3 represents market center. The lower D1, D2, D3 represent the quantity demanded by market centers. Now check the cell C11. C11 is a cost of transportation. 1 unit of goods from supply 1 to demand 1, from the source 1 to market center 1. C12 means the cost of transportation of goods, 1 units of goods, from the source 1 to market center 2. Now, C22 in the middle row shows what? Shows the cost of transportation 1 unit from the source 2 to the market 2. But C33 shows what? Shows the cost of transportation of 1 unit of goods and services from the source 3 to the market 3, while C31 represents the cost of transportation of 1 unit of goods from what? From the source 3 to the market 1. Please center on D equal S. That means the problem is balanced. The problem is balanced. Now, D1 demand above, so lower row. So that means market center number 1 demands D1. Source or production center has number 1 has stock of S1. Production center number 2 has a stock of S2. Now, we are going to assign or to supply each market center. Each market center. For example, okay, this is the next step. Northwest corner method. Northwest corner method as a form of transportation problem is a technique for calculating an initial visible solution for a transportation problem. Obviously, its objective concerns with finding an optimal solution by minimizing the total cost of transportation. Steps to apply the northwest corner method. Step 1. Check if the problem is balanced or not. If not, balance the problem. What do we mean by the balance problem? Demand should equal supply. The quantity of demand should equal the quantity of supply. Step 2. Choose the first northwest cell of the matrix as starting point. We start to assign the requirements of that cell of the problem from the first cell of allocate as many resources as possible to the chosen cell. Now we have to check the requirements of the market center at that cell step by step. The first cell is placed on the northwest corner, the left side upper, and we are going to assign the requirements of this cell. Actually, the requirement of market center number 1 without exceeding the supply of demand constraint for that cell. If supply or demand of a row or column is completely satisfied, move to the next available cell in the remaining rows or column respectively. We will move to the next cell exactly when we satisfy the demand and supply of this cell. We are going to repeat step 2 and 3 until all supplies and demands are satisfied. These are the main steps which will be clear in the process of application. The main is starting point is the cell of the northwest corner. Okay, application of northwest corner. Given the following matrix, find the total cost using NWC method. Now this matrix has 4 marketing centers: D1, D2, D3 and D4, and has 3 sources of production: production center 1, production center 2, production center 3. Production center 2, 1 for example, has a stock of 300 units. Production center 2 has stock of 400 units. Production center 3 has a stock of 500 units. Now marketing center D1 requires 250 units. Market center D2 demands 350 units, and D3 requires 400 units. And the last marketing center, D4, demands 200 units. Firstly, let's check the condition of the problem. This problem is balanced because the total supply equal the total demand equal 1200 units. So we can apply the method of northwest corner. As we mentioned before, the starting point of solution or assignment is the intersection cell between D1 and source 1, between market center number 1 and production center number 1. The cost of transportation 1 unit from the source 1 to market center D1 is $3, for example, for 1 unit. Okay, $3 is the cost of transportation 1 unit from the source 1 to the market center D1. Market center D1 requires, check the row of demand, the last row, the lower row, demands 250 units. The application should start with D1 and source 1. Now, source 1 has a stock of 300, while market D1 requires 250 units. So we can supply the needs of D1 and state inside this near the number 250. I'm going to write here 250. The remaining stock is 50 units. Okay, now market D1 is satisfied. Now still source 1 has 50 units. We will move to the next row unless the supply and demand is finished. Now we will move to the next right cell, D2. D2 market center D2 demand 350. And source of production center has 50 units remain from 300. we can satisfy the market center with the remaining 50 units. We are going to state 50 units near the cost 1, and we will cancel the 300 as we cancel the 250. Still D2 requires what? Still D2 requires 300 units. Once we cancel the source number 1 and the market center number 1, then we will move to the next row. The first cost under the column of D1 we will escape because D1 has got its demand. So then we will move to the next cell where is cost equal $6. In this row, source number 2 has 400 units. D2 has only 350 because 300 only. The 50 was supplied by source number 1. So we are going to state 300 here near the cost 6, and we will cancel the demand of D2. But still source number 2 has 100. It remain from 300 negative 400 minus 300 remain 100. Then we will cancel D2 and we will move to D3. D3 here 0, here 0. D3 requires 400 while source 2 has 100. We will supply D3 with 100, the remain is 300. We will state near the cost 5 100. Okay, here still D3 wants 300. We will cancel source 2 and we will move to row 3. D1, D2, source 1 and source 2 are cancelled. Okay, now D2, D3 wants 300. Source 3 has 500. We will push 300 to D3 where cost equal 3. The remain here for source 3 is 200. The 200 stock will satisfy the needs of D4. So here 200 near the cost, we will near the cost equal to, we will state 200. Near the cost 3 we will state 300. Everything is 0. D1, D2, D3 now is equal 0. The demand of D1, demand of D2, demand of D3, demand of D4 equals 0, and the source 1, the stock of source 1, source 2, source 3 equal 0. We finished. Let us show this practically. That's why I don't like. Okay. Now, to simplify the solution, let's name the sources. The first source is Coca-Cola. The second source is Pepsi-Cola. And the last is Pesianos. Okay. Now, the cell C11 or D1S1, a cell of D1S1 demands 250 units as stated, and the column of D1. Look at the column of D1 at what? At the in the demand row. Demand row, the last row, shows that the market center D1 requires 250, and S1 Coca-Cola has only 300 units. S1 has 300 units in its stores. كوكاكولا عندها 300 زجاجة بتاعت كوكالا في المخزن بتاعها. مركز التسويق D1 عاوز 250 منها. طيب, let's see. So Coca-Cola has 300 units. We mentioned that we have to start from the cell. The first cell represents by the row of Coca-Cola and the column of D1. So market center number 1 requires 250. Coca-Cola has 300, more than 250. So we can satisfy the demand of D1 totally. Then we are going to state 250. We satisfy the total demand of D1, then we will cancel 250 and 0 instead of 250. Then we will move to the right side to D2. Now, first check. D2 requires 350 units. Coca-Cola previously gives D1 250 and it has 300. The remain for Coca-Cola is 50 units. So Coca-Cola can supply D2 with the 50 units. 250 plus 50 is 300. So now Coca-Cola has no stocks. After we satisfy the needs of D1 and the stock of Coca-Cola is finished, then we will move to the next row. The first column which intercepts the next row or the Pepsi Cola has no needs because its demands is already satisfied. D1 has no needs. We will move to D2 where its cost equal 6. D2 requires 350 units and Pepsi Cola has 400, 400 units. But this 350 100 now it's 300 only because previously we satisfy D1 with 50 units. The remain is 300 only. So Pepsi Cola can satisfy D2 with its 300. The summation add 50 plus 300 is 350. The remain stock for Pepsi is 100. Pepsi Cola gives D2 300. The remain is 100. Then we will move to the next D3. D3 wants 400, but Pepsi Cola has just 100. Coca-Cola can give D3 100 and the stock of Coca-Cola is finished now because 300 plus 100 equal 400, but D3 still wants 300, now then D2 equal 0 and Pepsi Cola now has no stock. Then we will move to the next Bizianos. The market center D3 still wants 300 because 100 is satisfied before by Pepsi Cola. Bizianos can satisfy market center 3 by 300 because it has 500 units. The remain now for Bizianos 500 negative 300, the remain is 200. 200 in the stock on the store of business of Bizianos is required by D4. D4 requires 200. 200 then is 0. All markets has 0 stocks. All market center now has 0 demand. Then the problem is solved. Now we are going to calculate the total cost of transportation. To calculate the total cost, we will pay attention only to occupied cells, which consists of quantity of product and its cost. For example, take cell D1 1. It contains cost 3 and quantity 250. Then the total cost of this cell is 3 times 250, which is 750. The total cost of the problem equal to summation of the total cost of cells. Then the total cost equal 300 times 250 plus 1 times 50 presents the first row, 50 for the D2, 100 is the cost of transportation, 1 unit from S1 to D2, plus 6 times 300 plus 5 times 100 plus 3 times 300 and 2 times 200. The summation of this operation or calculation is $4,400. This is the total cost of transportation 1,250 units from all sources to the all market centers. Actually, we transported 1,200 units from 3 sources to 4 market centers. The cost of transportation this 1,200 units equals $4,400. In the next methods موني كيفك أخبارك. In the next methods we are going to minimize this total cost using least cost methods. We will improve our optimal solution. Okay, let's introduce with the least cost methods. As we mentioned before, transportation problem has 3 methods: northwest corner method, least cost طريقة أقل التكاليف method, and Vogel's approximation method. The least cost is another technique used to obtain the initial visible solution or optimal solution by minimizing the total cost of transportation. Steps to apply the methods of least cost. As usual, we need to balance the problems. If not, to satisfy the condition sigma supply equal sigma demand. select the lower cost from the entire market and allocate the minimum of supply or demand. We are going to select the lower cost from the entire market and allocate the minimum of supply or demand. Then remove the row or column whose supply or demand is fulfilled. Repeat the same procedure until the allocation is over. So the main pointer in this method is the least cost. Choose the least cost and allocate the needs of the cell which contains that least cost. We are going to repeat the same procedures, the same steps until the allocation is over. The allocation is over means each market center has been satisfied, then its total demand equal to 0, and respectively each stock of equal to 0. The application of least cost methods. Given the same matrix or of which we gave it to the we use it to apply the northwest corner method. In order to compare the two solutions, the solution of the north corner methods and the solution of the least cost method. That's why now we are going to fix the same matrix. Required is find the total cost using the least cost methods. Given, of course, 3 sources and 4 market centers and stock of each source and the total demand and the condition satisfied, the total supply equal the total demand equal 1200 units. The main tool in this process, the main starting point is the least cost. So we will start our solution with the cell of intersection point between D2 and source 1. Between D2 and source 1. Now we will go to the next slide to see practically how to apply the least cost methods. Remember that the initial point to solve this problem is the least cost, which is shown in the mentioned matrix equal the least cost in this matrix equal $1. The intersection point between D2 and source 1. Unexpected error. We rearrange our previous solution. Now the matrix has another shape. Okay, now we will repeat the same steps with the same regulations. We are looking now for the least cost in this matrix. The least cost equal $1. This least cost replaced in the cell of intersection point between D2 and source 1. Then thus follow the demand of D2. D2 demands 350 units, but source 1 has only 300. Then we can satisfy the needs of market center 2 by 300 units. Now the stock of source 1 equal 0 because it gave D2 all the total of its stock, which was 300. Move to the next least cost. The next least cost equal 2. 2 is intersection point between D1, market D1, and the row of source number 2. D1 requires 250. We are very lucky that source number 2 has 400 units, so we can supply the total needs of market 1 by 250. The remaining stock to source number 2 is 150 units. Then let's move across this row. The next least cost in this row is $5. $5 is common cell between D3 and source 2. D3 requires 400 units. The remain for source 2 is 150. Then source number 2 will give D3 150. Now the stock of 2 equal 0, but D2 still needs 250 units. The stock of 2 is finished. Then we will go to the source number 3. The least cost in this row is $2. $2 is the common cell between D4 and source 3. D4 requires 200 units. Source 3 has 500 units. So we can supply the needs of D4, and the remain stock for source 3 now is 300 units. We will divide these 300 units between 250 for D3 and 50 for D2. So after this long calculation, now demand D1 now demand 0, D2 demand 0, D3 demand 0, and D4 demand 0. So stock of source 1 is 0 now, stock of source 2 0, stock of source 3 equal 0. The matrix solution of matrix is satisfied. Just the summation of the stock in column D1 250, the total of quantity in column D2 300 plus 50 is 350. For D3 is 150 plus 250 is 400, and D4 requires 200 is 200. Now let's calculate the total cost by the operation of multiplication. Starting from D2, the cost is 1, should be multiplied by 300. 1 times 300 plus 2 times 250 plus 5 times 150 plus 3 times 50 plus 3 again times 250 plus 2 times 200. The total cost now is 2,850. Least cost methods usually gives more optimality compared to the northwest corner method, which was which was 4,400. Fugel approximation, cost penalty methods. The one of the most effective method of transportation problem. It gives very optimal solution, compares with the previous method, is used to allocate the optimal solution by minimizing the total cost. However, VAM is an abbreviation of Fugel's approximation method. Is an iterative procedure such that in each step we should find penalties for each available row and column by taking the least cost and the second least cost. Of course, steps balance the problem. If not, demand should equal supply. Identify the two lowest costs in each row or column of the cost matrix. State the absolute difference between these two costs. These differences are referred to as penalties. Find the row or column with highest penalty. Assign the minimum of supply and demand to the corresponding cell. If there are multiple rows or columns with the maximum penalty, you can choose one of them. If the assignment from the previous satisfies the supply at the origin, delete the corresponding row. If satisfies the demand at the destination, delete the corresponding column. Now we are going to apply these theoretical approaches or theoretical steps using the same given matrix or previous matrix in order to compare the three solutions and to prove that the Fugel approximation model is the most effective than others. This is شنو؟ لا باكل بشرب الشاي بتاعي. Now we are going to apply the Fugel's approximation model using the same matrix, above given matrix, in order to, as mentioned, to compare between these three methods to compare its optimality. If the supply at each origin is 0, the steps, and demand at each destination is 0, stop iterate. That means we finish our solution. Otherwise, repeat the above steps. Given the above matrix, find the lowest cost using the VAM. Here penalty refers to the difference between the lowest two costs in row or column. Now, we will start with the last column, the right side, on the right side, and the last row in the lower side. Now, let's find the penalties for the rows. Row number 1 consists of 4 costs: 3, 1, 7, 4. The two lowest costs are 3 and 1, so the difference between them is 2. Its penalty is 2. Move to the row number 2 where costs are 2, 6, 5, 9. The difference between the least two costs, 5 negative 2 is 3, and the last row has 8, 3, 3, 2. The difference between two least costs is 1. 3 minus negative 2, 1. Now, let's go to the first column, the column of D1, and find the penalty. The difference between two least costs is 1. 3 negative 2 equal 1. Move to the column D2. The difference also is 2. D3, the difference between two least cost is 5 negative 3 2. D4 is 2. 4 negative 2 is 4. Now step 1. Step 1, to find the difference between two least cost in each column and in each row. Now check the highest penalty regardless its place. The highest penalty is 3. Three replaces in the row 2. The lowest cost in this row is 2. 2 is a common cell between D1 and source 2. Okay, between D1 and source 2. D1 requires 250. 250. Source number 2 has 400 units. Then source number 2 can give D1 250. The demand of D1 now equal 0. But stock of source 2 now is 150 because we cut this stock by 250. 400 negative 250, the remain is 150. Okay, now then go to the least. Now we are going to the least cost. We have 4 options because the highest penalty had 3 options. 4 twos. Easier to choose 2 for row 1 or 2 for column D1 from D2, D3 or D4. Now let's start. Let's choose the penalty in the row 1. In this row the least cost is 1. The least cost is 1. Okay, 1 is the common cell between D2 and row 1. D2 wants 350. Source 1 has 300. So source 1 can give D2 the 300. Now the stock of source 1 equal now 0, but D2 is still requires 50 units because the demand of D2 equals 350. Okay, let's move to the next highest penalty. Choose penalty under the column of D4, which is equal to the least cost under the column D4 equal to. Choose is a common cell between D4 and source 2. So source 2 has 500 units, so it can give D4 200. The remain stock for source 3 is 300. Now the demand of D4 now equal 0. Okay, let's move to D3. D3 requires 400. We will give D3 250. The remain is 150. 150 can be supplied by the remain of the stock of source 3. Now D1 now wants 0, D2 wants 0, D3 wants 0, D4 wants 0, stock of source 1 0, stock of source 2 0, stock of source 3 equal 0. Okay, now let us calculate the total cost. The total cost now is 100 times 3 $1 times 300 plus $2 times 250 plus $3 times 150 plus $3 times 250 plus $2 times 2000 equal 2400. Compared to the previous minimization, this is the best cost. This is the best cost. That's why the Fogel approximation model gives very optimal solution compares with other methods.